name is Balqis and welcome to Group 4. We will be presenting about multiple loop circuit. But before that, what do we know about multiple loop circuit?
Circuit, we can get three equations. Actually we can get more, but we just need three of the equation because we have to find three unknown, which are I1, I2 and also I3. So from this equation we just need to plug in the value of R, resistance, C and also L, which is the inductance. So from the equation 1 we will get 4I1 plus 20I2 prime equal to sine 2t, and also in the equation we will get 20I3 prime minus 2I2 prime is equal to 0. So from this equation, if we derive it, we bring the prime one to the left hand side and left the other to the right hand side, we will have I3 prime is equal to sine 2t minus 4I2 minus 4I3 over 20, and also I2 prime is equal to sine 2t minus 4I2 minus 4I3 over 2. So our proper solution is x prime t is equal to at xt plus with ft. Ft is considered as some function, so it will produce our solution to become non-homogeneous solution. We will have non-homogeneous solution. So our E from the equation that we get, we have negative 2, negative 1 over 5, negative 2 and negative 1 over 5. Then we just plug in this A into the proper solution, so we will have, so now we need to find the eigenvalues and also eigenvectors. So to find the eigenvalues, we need to consider a minus ri, like the determinant, which is equal to 0. So at our identity part, we need to minus with r. So r is we will get r equal to 0, and also r2 is equal to negative 11 over 5. So after we have found the eigenvalues, so now we need to find the eigenvectors. So when r1 equal to 0, so we just need to find the corresponding eigenvectors. So when the eigenvalues is r1 is equal to 0, so we get the eigenvectors is 1 and negative 1. Consider that t is equal to 1. Then same step for the another eigenvalues, so that we get the eigenvectors is 0 and 1, 10 and 1. So our homogeneous solution will be C1 negative 1 plus C2 exponent is our R2 value, negative 11 over 5. So negative 11 over 5t, 10 and 1. But this is only the homogeneous part. We need to also consider the particular.
Then, we seek for a particular solution in the form of xp equals to function x times function v, where function v is equal to integration of inverse of x times function f with respect to t. In the previous part, we already obtained the function of x. Then, we evaluate the inverse of it. After that, we multiply the inverse of x with function f. After we obtain the function of v, we put back in the proposed solution. Therefore, our particular solution is this. After combining the homogeneous and particular solution, we got our general solution, which equal to I2 and I3. So, we got our I2, which is this, and our I3, which is this. Next, by using initial condition, when t equals to 0, I2 and I3 equals to 0, therefore, we found our C1 equals to 0 and C2 equals to 5 over 442. Lastly, using the equation of I1 equals to I2 plus I3, we obtain all the currents, which is I1, I2, and I3.
And I3 by knowing the value of its resistance, charge, and inductance. Metric method is being used. As we can see from the graph, the current will be reduced over time. The graph shows how two of the currents will go over the time. Current that is being considered are for I2 and also I3. If the experiment be continued, the graph will not show much changes, but for sure, there will cause some changes if the experiment is being done with different value of resistance, inductance, and charge. For conclusion, we discovered that the analytical circuit is one of the applications that use the theories of mathematical methods. We have studied that method of variation of parameter can be used to solve the particular solution to the non-homogeneous linear system in multiple loop electric circuit. We also apply Kirchhoff's circuit law that can be divided into two, which are Kirchhoff current law and Kirchhoff voltage law. The solution from these linear systems give us the values of current. Then to verify it, we use Mapper software to plot graph of the current in these multiple loop circuits. Then we successfully get the same general solutions from these two approaches.
Recommendation, as stated by the Ohm's law, we know that V is equal to IR. As we know, V is voltage is equal to current time with resistance. For For this case, if we want to increase the current, we must increase also the voltage. So this is because voltage is directly proportional to the current. So this means that if we increase the voltage, we also will increase the current.